Welcome to week 5 of memory. Make sure before you start this PowerPoint that you actually open up your textbook. Yes, I do want you to read and have a read over page 232 to 233 of your textbook. That's only one page, so make sure you have a good read through it in detail. Hopefully now you've had a read through that one page of your book, and we can have a chat about the 3 main processes of memory. So these are 3 terms that we're going to use throughout the next 4 weeks that you need to have a really good understanding of what they mean. So that's encoding, storage and retrieval. And to help explain these 3 terms, we often give you an example of a computer and how a computer does these 3 processes, and then how the human memory, us as humans, do these 3 processes. So the first one is encoding. And encoding involves putting information into a usable form for storage. So for example, when you hit the A key on your computer, an A actually doesn't go into the computer hard drive. For those people that know anything about computers, computers work on a binary code, which is a series of ones and zeros. So the letter A on your computer might have a 101 code attached to it. So the information that we see on the outside is different to the information that's received by the computer on the inside. So you can think of that word encoding as changing. This happens for the human memory as well. Information that we get from our outside environment is in one form of energy, and the type of energy that the human brain is able to transfer is called electrochemical energy. So I'll give the example of sight. Visual information is in the form of electromagnetic energy, but the body cannot transfer electromagnetic energy. So when that comes into the eyes, the rods and cones in the eyes, which are cells in the eyes, are responsible for changing that energy into electrochemical energy. And it can only leave the back of the eye once it's changed into that energy that the nervous system can actually transfer. So for computers, the letters are changed into a code that the computer can understand. For humans, the outside energy is changed into electrochemical energy, which is the type of energy or messages our human body understands. So encoding means changing. That's the first step that needs to happen for any information to even be understood. The second step of the course of memory, of course, is storage. So the implication of memory is that if we store it, we can then use it later. So storage is pretty key. For a computer, this tends to happen on the hard drive, and for humans, we know that this happens in the brain, in lots of locations in the brain, and you'll learn that a little bit more over the next 4 weeks. Retrieval involves getting this information back from the brain and into conscious awareness. So getting the information so it can be worked on. For a computer, it means after you've saved it in a file on the hard drive so it can be stored, that you can then go to that same file and open it up on the screen. And the screen is like the computer's awareness, what is being held in its attention span at that period of time. And we know that during the period of time that that piece of paper or that file is open on that screen, that you can change the file, you can add to it, you can make it better, and then you can save it back onto the hard drive. Human memory is much the same. We can bring, and that should say bringing with a G, we can bring the memory back into conscious awareness. So our computer screen is our consciousness. We can then work on the memory, so we can talk about it, we can enhance it, we can understand it some more, and then it can get stored back in our brain once we have finished working on it. So if I said to you 8 times 8, you would have to go to your storage system, your brain, retrieve your 8 times table. You would do the work in your conscious awareness, and then once you have finished with that, so you would have retrieved your 8 times tables, you will then store it back into your memory. So encoding, storage and retrieval are 3 terms that you need to know well. I want you to stop again and have a read through pages 233 to 248. There's a lot of pages there, so you don't need to read it in detail, but just briefly flick through and do a bit of skim reading. I'll see you in the next slide. Okay, in class at some stage this week, you'll get a diagram of the flow chart of a particular model of memory called Atkinson and Shiffrin's multi-stall model of memory. So these notes will accompany that flow chart, and the next couple of presentations or videos will also accompany that flow chart. So basically Atkinson and Shiffrin, that's just the name of the two people that researched this model, and the multi-store model suggests that there are basically 3 different stores of memory, and they function simultaneously, so at the same time, but they interact with each other and work together. And Atkinson and Shiffrin said that there's a sensory memory, a short-term memory, STM, and a long-term memory, LTM. The sensory memory is a brief memory store, so information doesn't stay there for very long. It depends what sensation we're talking about as to how long the information stays there. Generally a fraction of a second through to 3 to 4 seconds. And information will only move on from sensory memory to the next memory store, which is short-term memory, if you actually pay attention to it. So at the moment, my voice could just be hanging out in your sensory memory because maybe you're paying attention to Facebook instead of me. However, if you are paying attention to me, the information should be moving on to your short-term memory. It has an unlimited capacity. There's no limit to the things that we can turn our attention to if we want to. Where the colour of the wall, the colour of the ceiling, the feeling of your hands on the table or the computer in front of you. So it's only there for a limited amount of time, but a lot is there available to us in our sensory memory. If you pay attention to it, it will move on to your short-term memory. And short-term memory is a limited store in that it only holds approximately 5 to 9 items. And we tested this in class for most of you, and if you haven't, we will do that later in the week. So we know that not a lot of information stays here, and we know that as new items come in, the old items must fall out. So if you can remember 9 items, the minute you remember a 10th, that means the first of those 9 items will have dropped out. This is where our conscious awareness happens. So anything that you're thinking about at the moment means that you've attended to it and it is now in your short-term memory. So short-term memory or your conscious awareness. This information generally only stays there for 20 to 30 seconds. And after this time, if you've done no further work to the information, it will drop out of your short-term memory. If you do some work, it has another option, which is moving on to long-term memory, which of course is our goal. Long-term memory, this is why we want information to go there, because it's relatively permanent, and also there's no limit to how much information we can store there. So we don't have a 2 gig hard drive, we have an unlimited hard drive. Providing we are healthy and well, there is no reason why we can't continue to form and store memories appropriately. The only reason we don't say that it is definitely permanent, but rather we say relatively permanent, is because there are occasional times when memories can be lost, and that's if you sustain some brain damage, perhaps if you have alcohol-related amnesia. That would be quite significant damage that you would need to receive. Most of the time, memories are relatively permanent. We know that sometimes we can't find them, so they're available but not accessible. So that term relatively permanent is talking about the availability of those memories. When we consciously think about a memory, it comes out of our long-term memory via the process of retrieval and back into our short-term memory, which again is our conscious awareness, where we can work on it, and then it will go back to long-term memory again. So it's like we bring it into our screen, we do some work, and then we store it back into long-term memory. Hopefully this has just given you a brief overview of the model so far. There's a lot more detail that you'll need to know, but in the next video, we'll start breaking up each of the components. So the next video will focus just on sensory memory, which hopefully you will see soon. Just a little fact to leave you with, and that's that sleep actually improves memory. And I thought that this was an interesting fact to put up because 10 o'clock, maybe even 10:30 the night before the SAC, a lot of you were up on Facebook. And if you are worried about your SAC and actually retrieving information that you've learnt throughout the day, sleep is a vital part of that, and you'll learn why in the coming weeks. All right, right, thanks for that, and I'll see you in the next video. Make sure that you've taken your notes, and I hope that you've enjoyed this. Catch you later.